numbers given the scientific notation, first, we're going to compare the exponents. All right, so we're going to look at the exponents first. Now, the exponent is just like a number line, okay? The larger the exponent, the bigger the number. The smaller the exponent, the smaller the number. All right, the same with negative. So, like -2 is smaller. I'm sorry, yeah, -2 is smaller than 0. All right, so then if it had -2, it's going to be smaller than something that's raised to 0 power. All right, so first you're looking at the exponents. The one with the greater exponent obviously will be larger, okay, or bigger. And then if the exponents are equal, you go to the decimals, okay? Because the exponent, obviously, if something's like exponent third, both in third power, then you'll compare the decimals. So like 3.5 times 10 to the third, and I don't know, 2.6 times 10 to the third. The 3.5 will obviously be bigger because 3 is bigger than 2. Okay. So the first one, we're going to compare 6.23 times 10 to the 14 and 8.92 times 10 to the 12. All right. First thing we're going to do is we're going to, so we'll just put step 1. All right. We're going to compare exponents. So I look at their exponents. All right. 12, this is raised to the 14th power. So just by looking at those, the 12 and the 14, which one is larger? The 14. All right. So I guess I'll write it like a note. See, 14 is greater than 12. So 6.23 times 10 to the 14 is greater. Okay, so this number is larger because that exponent is larger. 14 is bigger than 12, which makes that number larger. Okay, so since 14 is greater than 12, 6.23 times 10 to the 14 is greater. Okay, than 8.912. Now, sometimes what's confusing is you all may look at these and you'll look at the 6 and the 8. You'll forget about the exponents. You might say, oh, this one's bigger because that number's larger. Okay, exponent first. If the exponents are the same, then we go to the decimals. Okay. So number 2, what we're going to do is we're going to look at the exponents first. -4 and -5. -4 and -5, which one of those numbers is larger? -4. Okay, we're determining larger. Think about the number line. Okay, if something's closer to 0, all right, then that number is going to be larger when it's on the negative side. Okay, so this number, okay, is larger because you don't have to write this down if you don't want to. I'm just writing it down in case some of you need to. Because -4 is greater than -5. Okay.
So it just all depends on the exponent.
It depends on the exponent. If exponents are the same, then you go and you get order decimals. Yes, Dallas.
So like, can the two numbers that have the exponents, can they be different? Like the numbers, not the exponents.
These numbers here?
So like the 10, like with the 14.
Yeah.
Could the 10 be a different number?
No, because scientific notation is base 10s. It's always times 10 to the something. So now number 3 is a good example. We look at 3, my exponents are both 17. Okay. So when my exponents are the same, now I need to compare these decimal numbers out front. So 3.28 or 4.25, which of those two numbers is greater? 4.25. Okay, so this number, this one is greater. Okay, because we looked at the decimal numbers down front. So if the exponents are the same, you automatically go to the decimal number out in front. If the exponents are different, you automatically go to whichever exponent is larger, and that's gonna be your bigger number. Okay? And two, it's important to focus on what the question asks you, like, which of these two numbers is the smallest number? Because what we're gonna do is we're gonna get in a habit, if we get good at doing this, we're gonna look straight at the exponents, we're gonna look for the bigger one and answer it. We're gonna quit reading the question. And I've done, everybody does it. What happens, you get a little confidence, you get rolling, you forget to read all the instructions, then you get your test back, you got an 88 instead of 100, you're like, what happened? And then you're mad at yourself because you didn't read the directions. Okay? So just pay attention to that, because again, I think this right here is probably an easy concept for a lot of you to understand, all right? But the instructions, sometimes we gotta make sure we pay attention to those. Okay? This is gonna go away. See you back there writing, Caitlin, until they hit that mouse, it's gonna go. You good? Huh? I like doing exponents. I think it's, like, if you understand the rules, you can just roll. So order from least to greatest. So we're gonna order these sections of numbers, all right, from least to greatest. So when we look at those, let's focus on the exponents first, okay? When I look at my exponents, I'm gonna be able to pick out which numbers are the least. Now, if we look at the smallest numbers out of these, we can see -7 is obviously our smaller number, okay? Because when it comes to the negative side, whatever number's farthest away from 0 is your smallest. So if these are the same, I need to focus on these numbers out in front. 2.81 or 2.72, which one's smaller? 2.72. So we order these, we're gonna have 2.72 times 10 to the -7. And then obviously this will come next because we were comparing those two. 2.81 times 10 to the -7. All right. So what's going to come next, the 3 or the -4? -4. So this will be 9.45 times 10 to the -4. And then obviously my last one, 2.01 times 10 to the third. Oh, you guys are looking at me like this is really easy. Come on, let's go. Pick up the pace. But again, this whole unit has been a lot of review from last year. All right. Okay, we'll look at these next four. I'll give you all a second to kind of look at those and try to work them in your head. Remember, you're going to use less than, greater than, or equal to, and then we'll go through them. You don't have to run out. You just kind of think about it, get your answer, or go over and see if you understand or not. Okay, and you're looking at me all funny. Okay.
Oh, I'm just trying to read it.
Oh, okay.
Do we have to write everything?
No.
Oh.
Notes are totally up to you. I'll rather you write them down, but like a lot of stuff you can abbreviate it, just make it your own, as long as you understand the numbers. I'm cool with that. All right, so this first one here, greater than, less than, or equal to. Greater than. 5 is greater than -7. Okay, number 2, greater than, less than, or equal to.
Less than.
Less than. So we got my 4 and 6. 6 is greater than 4. This one,
Greater than.
-2 is greater than -6. And the last one, greater than. My 5s are the same, so I have to go and compare, and 5.27 is greater than 2.139. I promise you all it's that easy. The exponent is greater, the number is larger. Okay? If the exponents are the same, then just focus on your decimal numbers. All right? Any questions on any of that? I don't feel like I have any. Okay. All right. Let's go and let's get into the learning check. Go ahead and open it up. I will open up the, oh, it's already open. All right, cool. I thought I closed it. It should be learning check 13. All right. Now you can either stay with me question by question, or if you're confident, you can go ahead and work ahead. It's up to you. Which of the following is equivalent to the expression below? Remember that exponent is repeated what? Multiplication. Same thing on number 2. Which of the following is equivalent to the expression below? Can you go to 3? Which of the following has the same value as? So if I had, these are multiplied, they have the same base. When they're multiplied with the same base, what rule are we using? Your exponent rule. What's the answer to the multiplication problem? Product. Product rule. What do you do with the product rule?
It's over there on the board if you need help.
That's right. Same base, keep the base, add the exponents. Can we move on? If you're ready to slow down, let me know. Same question. Which expression is equivalent to 7 to the 5th times 7 to the 10th? If you have the same base, remember to keep the base, add the exponent. Five. So the following is equivalent to 4 to the 5th over 4 to the 3rd. Quotient rule, same as the product rule. Same base, only you do what with the exponents? Subtract. Keep the base, subtract the exponents.
Well, if it's a fraction, you subtract it.
Yes. And I would always do, like I told you guys that day, I would always do top to bottom. Just like if I had x to the a over x to the b, I would always do x to the a minus b if you're unsure. Okay, because when you do that, then you might, if you get a negative exponent, you can flip it. But now, b, okay, if you're not confident with this, I would do it like this. But if you are confident, let's say if I had 6 to the 3rd over 6 to the 9th, well, instead of doing 6 to the 3 minus 9, 9 is the bigger number. So I'm going to do 1 over 6 to the 9 minus 3. I know it's going to be down here because that number is larger. When I subtract those, it'll automatically be a negative. So I'm going to flip it anyway. But now, this is something like, I'm really confused with that. I want to stick with this, stick with that, because you'll get the same answer. So thing, simplify. So keep your base, subtract your exponents. Everybody good? All right. Martha was asked to write a to the 48th power as a product of 2 powers with the same base in 4 different ways using only positive exponents. Which of the following could be one of Martha's expressions? So she's asked to write this as her answer. Okay, using the product rule as a product of 2 powers with the same base. Okay, so the base is the same. We're doing the product of the powers. So which one of those could be one of hers? Just for example, if you worked all these out, like a would be a to the 5 plus 8. 5 plus 8 is not 48. Okay, so you're doing A, B, C, and D, using your rules, which one of those rules will give me A to the 48th power? Which of the following is equivalent to the expression x squared raised to the third power? That's gonna be your power to a power rule. What do you do with your exponents and your power to a power rule? Okay, so they're on the board if you get confused or forget. What's the value of 2 to the negative third power? Go to your negative exponent rule. What do you do with your negative exponent to make it positive? Please don't miss number 10. Anything to the 0 power is the same answer. Anything. Anything.